Today we are working on redox titration, experiment 7, and what we are going to do today, the goal of our lab, is to titrate hydrogen peroxide with potassium permanganate, solution potassium permanganate, and the reaction that takes place is a redox reaction in acidic condition. This is the unbalanced reaction, so let's see how we balance the reaction using the half reaction method that we learned in chapter 20. So first we figure out what is the oxidation number. If you remember, oxygen is -2, right? The oxidation number. 2 times 4 is equal to -8 because the charge of the permanganate anion is equal to -1. The oxidation number for manganese is +7. So manganese goes from +7 to +2, okay? And so what is happening? When the oxidation number is decreasing, we have a reduction. So we have a +5 electron here, because a +7 -5, because the electrons are negative, will give +2. So this is the reduction half reaction. The other reaction is taking place, the other half reaction is the peroxide that goes to oxygen, okay? Let's write down what is the oxidation number for the oxygen and for the hydrogen. So oxygen in peroxide, we learn in class, has oxidation number -1 and hydrogen +1. The oxygen goes to oxygen, molecular oxygen, so the oxidation number is equal to 0. And so, because we have 2 oxygen here and 2 oxygen here, from -1 to 0, we lose 1 electron. Because we have 2 atoms of oxygen, we lose 2 electrons, okay? So that's how we balance the electrons. We learned that the next step, let me erase this 1 second. We learned that the next steps, so +7 is the oxidation number of permanganate. The next step is, once we figure out what are the oxidized and reduced species, so this is the oxidation half reaction, we balance the oxygen using water. So we have 4 atoms of oxygen, and the 4 atoms of oxygen are balanced with the 4 molecules of water, okay, as a liquid, and the hydrogen that we have on this side of the reaction is added on this side of the reaction as H+ from the acidic condition that we are using. So how many do we have? 4 times 2, 8. 8 hydrogen plus cation aqueous. So now this is balanced. Now we balance this reaction. The oxygen is already balanced. Here I have 2 hydrogen. So I put 2 H+ here to balance these 2 hydrogen that get released. Aqueous. Okay? The oxygen is already balanced. I have 2 here and 2 here. So now that we balance the both reaction, this is the reduction and this is the oxidation. What we're going to do is we are going to add together the 2 reactions, similarly to what we do in the SS law when we add the complete reaction. We've seen that before. And so, in order to do that, we have to balance the number of electrons on both sides. So let's balance the number of electrons. And let's multiply. We have 2 electrons here. Let me use a different color. 2 electrons here and 5 electrons here. So we multiply this half reaction times 2 and this times 5. And then we add the 2 reactions. So 2 times 8 is going to be 16 protons. The aqueous. The permanganate is going to be 2 permanganate ions plus 10 electron on this side. Here we have 5 hydrogen peroxide. And on this side, we're going to add this entire portion multiplied by these 2 factors. So I'm going to have 2 permanganate the 2 manganese 2 plus, aqueous, plus 8 molecules of water, plus 5 molecules of molecular oxygen, plus 10 electron, plus 10 hydrogen plus aqueous. So this is the final reaction. Then we check if we need to eliminate anything in this overall reaction. So 10 electron goes away with 10 electron here. We have 16 hydrogen plus here and 10 hydrogen plus here. So these 10 go away and this 16 becomes 6. The permanganate stays, the hydrogen peroxide stays, and this is our final reaction. Double check if I made any mistakes. You know that I tend to mix up things. Now let's look at the procedure, okay? So the procedure is very simple. We already done a multiple titration, so we should be very familiar with the glassware. We're going to use a 50 milliliter burette. You have it here. I have 2 here, okay? And you're going to use a 10 milliliters volumetric pipette with a bulb, okay? Right here. 100 milliliters volumetric flask, and then we're going to use 125 milliliters of Erlenmeyer flask to make our titration. We're going to wash everything with the ionized water, then the ionized water. We're going to check the tip. We are going to check that there are no bubbles when we flow the water through. Otherwise, we switch the burette. After we wash with water, we rinse everything with the ionized water. Okay? And so we are going to collect only 60 milliliters of potassium permanganate and not 150 to 200 like is written in the manual, because we don't want to waste the permanganate. And we're going to put it in a beaker. We're going to record the concentration of the permanganate, and we're going to transfer the permanganate. First, we're going to condition the burette in the way we learned before, right? We're going to put about 5 milliliters of permanganate in the burette, and then we are going to rinse the tip, and then we're going to condition the entire wall of the burette. We have a waste beaker where we are going to put the permanganate that we are going to use for the conditioning. And why do we have to do this? So that we don't change it by diluting the concentration of the permanganate. So once we do condition the purette with a permanganate, we fill it up to the 0 mark, which right now I cannot see. So now the permanganate is highly concentrated. And so what you want to do is you want to use a flashlight, maybe the flashlight in your telephone, to look at the 0.00 mark. And most likely you will perform a systematic error because it's very hard. It's very dark, this solution. So it's dark, purple dark. It's very hard to see. Use gloves for handling the permanganate because it stains your fingers. Okay, once you condition the burette, you take your unknown. Here there is one of the unknown. Record the number of the unknown. Okay, the code of the unknown, and you use the 10 milliliter volumetric pipette to collect exactly 10 milliliter. Remember that you have to collect to the mark, so you always go above. First you rinse it with the ionized water, then you rinse with a little bit of your solution so that you have the 10 milliliter volumetric pipette clean, and you don't dilute your original solution. And then you collect 10 milliliters, you transfer, you collect always more, and then with your finger, so practice in advance if you don't remember how to do, you go to the meniscus. The meniscus has to be, if you remember, if this is the line of the meniscus has to be above, touching the line, okay? So the lower part of the meniscus. And your eyes have to be aligned to the line that you have in your volumetric pipette. You transfer into the 100 milliliter volumetric flask, which needs to be rinsed with the ionized water, but doesn't need to be dried off, because you're going to add anyway water to the mark. And again, in adding the water, your meniscus has to be touching, the bottom of your meniscus has to be touching the mark, and the eye has to be aligned. So when you add the water towards the end, add it with a dropper, okay, with a plastic pipette, so that you control how much water you're adding. Then you do dilute the, after diluting the solution, you mix it by inverting the volumetric flask 10 times, okay, so that you have an homogeneous solution, and, well, not homogeneous, a same concentration solution. And then you take again, using the same pipette, 10 milliliter of solution from this volumetric flask, and you pour it into your 125 graduate cylinder. You add about 25 milliliter of ionized water, and then 50 milliliter of concentrated sulfuric acid. The sulfuric acid is in the hood. And you make sure that your solution is mixed. Don't forget to always use your wash bottle to clean the walls of the permanganate, the splashes, when you're performing the titration. Because it could be that that drop will help you to reach the end point of your titration. Have a white paper underneath and white paper on the side of your apparatus for the titration, so that you can titrate until your solution reaches a faint pink color, okay? So you perform 3 titration, okay? At least. The first one is going to be your dirty titration, in which you approximately determine how much permanganate you need to use for each titration, right? And then you have a 3 precise titration. What does that mean? That the volume that you're adding to the peroxide solution has to be, you're going to read the 4 significant figures. So let's say that you're adding 21.64 milliliters. They have to be the same to the 3rd sig fig, okay? And the 4th sig fig is your interpretation of your reading, okay? Once you're done, the titrated solutions go in the inorganic waste. You know where it is, the white bin. The unutilized permanganate goes in the brown bottle that says waste excess. It's not waste. We recycle. We don't want to waste anything, okay? So we recycle in these brown bottles the excess of not utilized permanganate. The excess of the unknown peroxide that you have here left over can go in the sink, because the hydrogen peroxide is diluted with water, so it's not harmful for our pipes or the environment. Okay? Any question about this? You guys have any question? No? All good? Alright, so let's get started.
This is lab 7, and this is the potassium permanganate that we're going to be using for our experiment. So record its molarity to the correct number of significant figures. Okay, so this is for experiment 7, and so record, this is the unknown solution that we're going to be using, so record its number. Okay. Now we're going to be diluting the solution, so using a 10 milliliter pipette, we're going to draw 10 milliliters of the unknown into our volumetric flask. Wait, where's the line? Okay. And then dang, that went above. I was like right at the meniscus.
I can edit the part out.
Yeah. I get it now. Dang it. It went right below.
Do you want to do it without a glove?
No, it's fine. It's
That
fine.
make you want to
It's
offend
there. The meniscus is like 1 centimeter above or below. Okay. now that we've added 10 milliliters of the unknown, we're going to add deionized water to the line. I'll cover this.
Oh, very gentle. Oh, well, that's good.
Okay. And then we're going to be using a small pipette. This pipette, yeah. Just to get the last drops. We shake it and mix it thoroughly for 10 times, or at least 10 seconds. Now that we've added 10 milliliters of the unknown, we're going to add deionized water to the line. I'll cover this.
Oh, very gentle. Oh, well, that's good.
Okay. And then we're going to be using a small pipette. This pipette, yeah. Just to get the last drops. We shake it and mix it thoroughly for 10 times, or at least 10 seconds. Okay. So this is for experiment 7, and this is the sulfuric acid we're going to be using. So record its molarity. Okay, so this is for experiment 7. This is our first trial. So first we're going to be using a pipette to draw 10 milliliters of the diluted solution into our Erlenmeyer flask. So I'm just going to mix this before I draw some. Okay. Okay. Now there. Okay. Now that we've added our diluted unknown solution, we're going to close this, put it to the side. Now I'm going to add approximately 25 milliliters of deionized water. And here I have 15 milliliters of our sulfuric acid. I'm also going to be adding and add some deionized water to the funnel to draw out any remaining solution. And now we've completed our first trial preparation. So this is for experiment 7, trial 1. So record the initial reading of the burette. Okay, so this is for our first trial of experiment 7. So we're going to be titrating the solution. So while I'm adding the potassium permanganate, I'm going to also stir at the same time to make sure that's reacted the whole time. So this is for the second trial. This is the initial reading of the burette, so record it to the numbers of significant figures. So this is our next trial, and we're going to be titrating it. And yeah, this is the same thing.
So as we are reaching the end point of the reaction, of the titration, we want to rinse with the deionized water the walls of the Erlenmeyer flask and the tip of the burette often, so that we will make sure that we collect all the permanganate that might help us to reach the end point. This will increase our accuracy in the titration. Yeah, that's it.
Okay.
Okay. Okay, 3. Oh, going.
So notice that this is a very faint pink. This was our first titration.
Use a bigger paper.
This was our first titration. This one is our second titration, and the pink is very, very faint. If you want to see how it becomes really pink, you add one more drop. You see the color becomes much darker. But still is a really good titration because the color is still much lighter than this one. And you can keep adding drops of permanganate, just adding water to the tip. You don't even have to move the stop coat. See, now it's getting much pinker. So the very first time was, and the reading of the volume is, we need to shine the light, and you can look at that reading.
Can you hold this? Right here? Yeah, there you go. And no, I won't show the face. A second.
Is it good or one more?
Okay, 3, 2, 1. One more time, right now.
This is the end point of the second titration. Record the volume that you read to the second significant figure after the decimal point. We need to have consistent values of the volume, which means the values of the volume had to be plus minus 0.1 difference between each other. 0.01 difference between each other. Excuse me. Please record the reading for the third titration, the initial volume of permanganate, and then we'll go fast. We read that it was approximately between 9 and 10, so we'll add the first 9 milliliters all at once, and then we'll go drop-wise for the last few milliliters. Now?
Mm-hmm.
So as you can see, you drop the first few milliliters kind of quickly.
Almost there.
You see this solution is still clear. And then you keep adding. So the last few drops you add drop-wise, so that using the same technique as earlier, so that you are as accurate as possible in performing the titration. And almost there. One more drop, hopefully you will be okay. Clean the vessel, and here you are. You have a pink that is even fainter than this one. Let's add the one more drop just to see the difference. So this is the first,
Yeah, it's okay.
the second one, and the third. You see how, but this is still clear, so maybe we need to add one more drop. You went back to clear in less than 30 seconds because the color has to persist for about 30 seconds. Okay, so now is really pink. And we reach our endpoint again. So let's read the value for the third titration.
Okay.
If you're done reading the third titration, compare the data that you collected, and you see the first 3 significant figures of the total 4 that you need to record are the same, then you don't need to do any more titration. You can just stop at 3. If that wasn't good enough, then you do a 4th one. So let's do one more reading of the initial volume of permanganate for our 4th titration. And let's get started.
Go ahead.
Because now we're pretty sure about the volume that we need to pour, we are going to go very fast for the first few milliliters in adding our permanganate.
And you can see the bubbles and the solution. Now we go dropwise because we want to have as accurate as possible determination of our endpoint. Almost. Okay, so we reached again the endpoint. You see that every time becomes faster and faster the process. And so these are our other titration. Here they are. Let me turn around the paper so that you can see the difference in color between this is the first one, the fourth one, third one, second one, and our first one. Let's put it on a piece of paper so that you can see actual color. So this will be what we called our dirty run, and this should be all consistent in terms of number of milliliter that we added of permanganate. The colors are very similar to each other. We're done with the titration. Let's do our last reading of the volume. And this concludes the experiment.